and we'll move on to the next one to stay on time. And oh, it's me. So unfortunately, Carl is moderating me, so we will make sure that I am on time. And it's sort of following on from what George was talking about is how do we define a coordinated lunar resource evaluation campaign? And coming back to something Sam touched upon is the US space policy. If you dissect this document, the terms sustainability, sustained, and sustainable are used throughout this. And I highlight policy goal number 6, which talks about establishing a permanent human presence on the moon in cooperation with private industry and industrial partners, develop infrastructure and services that will enable science-driven exploration, space resource utilization, and feed forward missions to Mars, which was also highlighted in the United States Lunar Exploration Roadmap. Principle number 4 talks about the extraction, utilization of space resources in compliance with applicable law, and recognizing that those resources are critical for sustainable exploration, scientific discovery, and commercial operations. And these will also be used to encourage international support for the recovery of and use of outer space resources. So the messaging from NASA has been along those lines with regards to sustained long-term presence on the lunar surface, and overcoming decades and generations. Over the coming decades and generations, our presence will grow and use and develop the extensive resources of the moon. If we then look at other NASA documents, we need to know the reserve potential of lunar resources in order to fully develop exploration technologies and enable a sustainable space economy with supporting utilities and commodities, as quoted from this recent HEOMD document. And then finally, if we have a coordinated lunar resource evaluation campaign and make that international in nature, it can be compliant with the Outer Space Treaty, thus making sure that we follow the international laws that the United States has signed up to. So this is the crux of the presentation here. The critical data needed to define the reserve potential of polar volatile deposits. So if we look at the types of data, and we have a lot of these from orbit, but as George has pointed out, we really need to get down to the ground truth, because what we're trying to do is go from resources, you can see in the diagram on the right, to reserves, which has an economic implication. These are known quantities of known economic value, such that they can be extracted and refined and used at a profit. So I sort of, in this table, tried to put together this idea of we need to know composition. If we look at our 1 point of ground truth with the LCROSS data, we know that we're going to have to refine the ice in order to obtain water. There are a lot of impurities in there, but those impurities could also be used for other it could be of other uses within a sustainable lunar exploration program for humans. The form, is it a cement in pore spaces? Is it in layers? Is it in blocks? It is difficult to tell what the actual form is of these deposits from space. Distribution, horizontal and vertical, is going to be needed. Geotechnical properties are vital, because these are now in areas of the moon that we've never actually looked at before. So we really don't have any ground truth that actually gives us direct applicability to these very unique environments. We need to know the near surface regolith stratigraphy in order to understand buried rock populations, for example, as well as ice layer or block distribution. And because they are where they are, accessibility. So the shadow cam on KPLO is going to be very important to try and define pathways into these and out of these rather chilly environments where these ice deposits are located. So again, over on the right, the measurement, and this is what we're trying to get out of this workshop. What is the required data fidelity for the measurements that we want to obtain? Is it plus or minus half a weight percent? What is that? What implications does that have for informing both scientific, commercial, and exploration stakeholders? So Noah highlighted Holly Brown's paper, and I give her table there of the top 21 candidates based upon her analysis of that. I also point out that Kevin Cannon, who's going to be talking here, has a couple of papers that uses a different yet similar approach to get an ice favorability index at the lunar poles. But orbital data inform accessibility, but not the level of granularity needed for composition, stratigraphy, geotechnical properties, i.e. extractability, and distribution. They do not give clarity to the form of the deposits, although we know that there are surface deposits as well as subsurface deposits. So higher resolution orbital data could be used to better locate or target surface assets, and maybe instrumented penetrometers delivered from orbit could be used in the top 10 to give us an early win in terms of new data on these PSRs. So the needed spatial resolution is what do we actually need to define these things? We need to get to the ground. We need to get to the surface. Understanding the geotechnical properties is important for developing cost-effective extraction techniques, and this can't be done from orbit. So we need meter and decameter scale data sets for that. So there are a lot of PSRs to investigate. So we need to hit the top 10. We've got we could do immediate orbital phase that could put instrumented penetrometers down, get better neutron data. We could target those around the PSRs, and more capable rovers could yield types of data addressing the categories, and then data obtained informs science, exploration, and commercial stakeholders. And that is my talk.